Alright, here we go. Video number 12, which we're going to do on congruency. Everything to know about proving congruency. Now, I know, before we even get started, I know this is a topic that some of you really don't like, but that's why we're doing the video on it. That's why I decided to do it, because it's a topic where if you just write some of the right things, you can pick up a couple of really nice marks, okay? And some of the reasoning that you have to go into doesn't have to be too complex, okay? I'm going to try and right the wrongs with this subject and hopefully get the bits that we can, okay? So here we go. Let's go for it. First things of all, we've got to know what we mean by congruency. Okay, this isn't everything. This is everything we want to know about congruency. So, the first thing, congruency is what we have when we have two objects or two things, two shapes that are exactly the same. Okay, they are exactly the same. One of them might just have been rotated, might have been flipped over, but the two shapes are exactly the same. Okay. Now, we concern ourselves at crossover and at higher tier with triangles. And there are 4 different proofs as to whether two triangles are congruent or not. Okay. And those are our 3-letter rules. Okay. SSS, ASA, SAS, and RHS. Okay. Now, it's important that in terms of like just knowing stuff, we know those 4 proofs. If we know what those 4 proofs are, we can then look for the right bits of information. And even if we don't know what those 4 bits are, we're still going to look for the information anyway, but this will help us know how to finish the questions off. Now, each of these things means something specific, okay? And I think one thing that was missed when we went through it first time round is some of the specifics. So make sure that you listen carefully to some of these specifics. The first one, SSS, side, side, side. I mean, that's just as straightforward as it is. If you can prove that, if you can prove that all 3 sides match up. Okay, so if you've got 2 different triangles and the sides all match up, then you've got the 2 triangles being exactly the same. Easy enough. The next one, angle, side, angle. This one it kind of gets lost a little bit in translation. You don't have to have an angle, then a side, and then an angle. Okay? You could have 2 angles and any matching side. Okay? That's one important detail which I think was skipped over a little bit first time round. You can have 2 angles, okay, any 2 angles, but then you must have a matching side as well. Okay. The third one, side, angle, side. This one does have to be in that order. Okay. Essentially giving you a corner. Okay. We talked a lot in our advanced trigonometry video about needing a corner of information to be able to work with the cosine rule. Same thing with this. If we've got a side, then an angle, and then a side to form a corner, then we can prove that 2 triangles will be the same, provided the information matches up. The last one only works with right angle triangles, and that's because this one refers to a right angle, a hypotenuse, and any other side. Okay? The reason why this one shows congruency, if you imagine using Pythagoras, if you know your hypotenuse and any other side, you can work out what the other side would be. Okay? And this one essentially just is proof by Pythagoras. Okay? So, knowing what those 3 letters are, knowing what they mean, and knowing their specifics can help you finish the question off. Normally that would just be by saying, by an angle side angle proof, these 2 triangles must be congruent. Or by right angle hypotenuse side proof, these 2 triangles must be congruent. Okay, so this is how we would finish the question off. We need to know now how to get started with the question so that we can kind of meet somewhere in the middle. Okay? So, how do we start these questions off? Well, my point of view with these questions is look for things that can make your life easier. Okay? This top one is a big one. Okay? If you can find sides that they have in common or a side that they share, I'll add that in, a side they share, you can already prove that one of the sides is going to be equal. Okay? Imagine, like, if you had, just for the sake of looking at this, imagine if you had two triangles that linked up like this to make a parallelogram. This side here would be a side that they have in common, and so it must be the same. So that could be one of the sides in a side-side-side, angle-side-angle, or side-angle-side proof. Okay? It gives us options. Okay? That, looking for things that they have in common or things that they share, that can really, really help. Something else that you can do is think about the types of triangles that you have or the types of shapes that you're dealing with, because then you might be able to do some shortcuts. Okay? For example, if I've got an isosceles triangle, and I'm never confident that I've spelt it right, but I think I have. If I've got an isosceles triangle, I must know that two sides are going to be equal, because that's what an isosceles triangle is. But I also should know that the base angles are going to be equal as well. And if you can identify those as being equal angles, that might help you to then work out something else, and it might ripple along. For an equilateral triangle, that can make things very much easier, because you know that all three sides and all three angles are going to be the same. Okay? And again, once you know that some things are going to be equal, some things are going to be same, you can start to use that to then help you out with other things. Okay? The parallelogram is a very helpful one, just as with maybe a rhombus, because they have matching sides and matching angles. Okay? For instance, we know that the top and the bottom are going to be of equal length. We know the left and the right are going to be of equal length. We know the opposite corners are equal. Okay? And these are the kinds of statements that you would be able to use in creating a proof. Okay? Because if you imagine we had cut this down the middle, like this, I could now say that, this side and this side are they match up. They're equal, so I've got one side that is equal. This side at the bottom and this side at the top are equal, so that's two sides that are equal. And I've even got a third one, which they have. Oh, excuse me. 1 second. Okay, sorry about that. We've even got a side in the middle that they would both then share. So you've got suddenly lots of different options, and that's just from knowing the different angles and sides properties in a parallelogram or a rhombus. And even if we think back to our circle theorems, I don't think that you would find congruency mixed in with circle theorems, but there's no reason why not. You remember that from the center of a circle to the circumference, your radius will always be the same. So there you would form an isosceles triangle. Okay? So if you were trying to prove that two different parts of your two different triangles formed within a circle are congruent, then you would be able to use that to help you. Okay? Because once you know that two sides are equal, you know that two angles are equal. Okay? And as well as that, knowing your specifics for triangles and shapes with repeating sides, you've also got these special angle reasonings that we looked at way back when we were in year 9. Okay? Alternate angles. Okay? Those are angles contained within parallel lines that are equal on alternate sides of our diagonal. Okay? So, for example, those black lines or the blue lines. Okay, those angles are going to be equal. For corresponding, if you've got two parallel lines like we have in the parallelogram, then for corresponding angles, they're going to be in the same place but on the corresponding parallel line. Corresponding angles are also equal. Okay? So if you can match some of these angles up, you know, things like any of these pairs of angles, you might be able to use that to then help you figure out some other angles to help you work out a problem. Okay? Those would be corresponding angles. And co-interior angles, they're like if you imagine our parallelogram, or a corner of our parallelogram, these two angles should add up to 180. Okay? So congruency is very much a kind of topic where we're pulling together lots and lots of different facts, lots of different things to be able to prove that two things are going to be the same. Okay? And these could be all the different things that we keep an eye out for. Okay? It's all very well talking about what we need to look out for. We need to be able to see it in practice well, and also think about how we present our answer. Okay? With much maths, you think about showing your working, showing your method. With congruency, we've got to present our argument in a clear, constructive way. Okay? So, how do we structure our answer? For every statement that we give, we must give some reasoning. So if I say that two sides are equal, I've got to say why I think they are equal. Okay? So, let's take a look at our first kind of main question to do with congruency and see how we go through it. Okay. So, example number 1. I've got a parallelogram here. So I've got SRQP is a parallelogram, and I want to prove that SPQS. So this triangle here, I'm going to label that triangle A. And SQRS, so this triangle here, triangle B, are congruent. I want to prove that those two things are congruent. Now, our diagram doesn't have anything drawn on it. We need to think about what we know to do with parallelograms, to do with triangles, to be able to prove this congruency. Okay? And I'm actually going to do it 2 different ways because why not? And we're going to go for method 1. So, what would I do? Draw on your diagram. Okay. In an exam, you might have that the picture already has everything drawn on for you. You might not. It might be completely blank, like this one. Okay. So it would be up to us to draw on our diagram to kind of say what is going on. So I know that this side will be equal to that side. I know that they're both parallel. I know that the bottom side will be equal to the top side. And I know that they are both parallel. Okay. I know that this angle should be equal to that angle. And I know that this angle at the very top should be equal to this angle at the very bottom. And for a parallelogram, I don't really have anything else that I can add to that. That is pretty much everything that I could add. Okay. So, I've drawn on my diagram. Next thing, I want to pair up my information and reasons. Okay. And it's that second part that is really important. You've got to present it with your reasons. So, what do we know? We know that PS equals QR. Now, it's not good enough for us to just say that PS equals QR. We've got to say how we know that. So PS equals QR because opposite sides of I'm just going to write para, a parallelogram, are equal in length. There we go. Easy enough. Statement, reasoning. Got to pair them up. What else do we know? We know that PQ equals RS for the same reasons. I'm just going to quote above. I would be more thorough and I would write out the full thing again. I'm just going to run out of space otherwise. What else do I know? I know that SQ and QS are shared and therefore are equal. Wow, I can't spell. There we go. So, I've proved that one side is the same. I've proved that the other side is the same. And I've proved that a third side is the same, the one that they share. So what have I done? I've got a side, and another side. So what have I done? I've done an SSS proof of congruency. Okay, and I can stop there. I can end my proof. Okay. Now, our second method, I would also draw on my diagram, do what I did before. I would also pair up my information and my reasons. I can still pair up the sides because they're nice and straightforward. But I would then do something different at this very last stage. Okay. I could say that angle SPQ, so that's this angle down at the bottom, and angle SRQ are equal. I'd have to say why they are equal. They're equal because opposite angles I'm going to write para again for parallelogram, are equal. And it might feel like you're repeating it and saying the obvious, but you do have to do that with these kinds of questions. Okay? And for this one, we would have proved if we'd done the same up to this final step and then looked at the angles instead, we would have had a side, an angle, and a side proof. Because we would have had a corner of information for both of these triangles. Okay? And we can end our proof there. If I could spell. Good grief. Things are going... They're going well right now. So yeah, there we go. We have our proof in two different ways for showing that these two triangles are congruent. Okay? Now, a similar kind of situation here on the right. We want to prove that SAPS, so this triangle here, triangle A, and BRQB, so this triangle here, are congruent. Now, I've missed something off of this question, which is that A is the midpoint of PQ, and B is the midpoint of SR. Okay, so this would be the point in the video where I'm going to give you time to hit pause. You try and match up as much stuff as you can to see what you can prove. And I would match the stuff up, even if I don't think I can complete the proof, because you can still award marks for getting some of the statements right and why. So it's always worth giving it a go. So, countdown to pause. 5, 4, 3, 2, 1. Go for it. Sufficiently awkward silence for me to wait for you to pause, and now we're going to look at going through this video. Going through the video? Going through this question. Good grief, I'm going through the video. We're going to be here forever. Right. So, first thing, draw. Okay, draw on your diagram. Now, we know the PS and RQ are parallel. It's another parallelogram. And we know that those are equal in length. So that looks good. What else do we have? We have that PQ and SR are going to be parallel and equal in length as well. Now, I can narrow this down further. Okay. I want, because we've got these 2 points here, which are the midpoints, I can narrow this down slightly further. Okay. I know that each of these bits are going to be parallel. That's fair enough. And I know that each of these bits are going to be equal in length. Okay. So I know that PA is going to equal AQ, is going to equal SB, is going to equal BR. Okay. Now, that is a statement, so I need to give some reasoning as to why. Okay. Because A and B are midpoints. And whoops. SR equals PQ because opposite sides of parallelograms are equal. Okay, so we said that all of these sides are going to be, all of these parts are going to be equal to one another. I'm going to add that to my diagram. And I know that they are all parallel as well. Fair enough. What else do we know? We know that opposite angles in our parallelogram are going to be equal. So that angle SPA should equal this angle BRQ. Now, do we have any easy explanations with this? We won't need it, but we could show that because this top side and this bottom side are equal, we could show that this is a parallelogram, but that would involve extra steps. We do have enough information here to be able to complete our question. But we could show that this side and this side would be of equal length. But it would involve some extra explanations that, to to be honest, we don't need. So we need our info and we need our reasons. So let's go for that. Now, we're looking to pair up these two triangles. So there's an easy one for us. Just like in the old question, we got PS equals QR, opposite sides in parallelograms are equal. So there's one easy thing for us. We got one side. What else have we figured out? We figured out the angle SPA equals angle BRQ. Opposite angles in parallelograms are equal. So we've got a side, we've got an angle. If I can prove either another angle or another side, I will have completed my proof. So let's go for the other side. Seeing as we've got another side, we've got that PA is equal to BR, and we proved that above. We proved that PA is equal to BR from us doing this bit up here. So we've got a side, an angle, and a side. So we have an SAS proof of congruency. Okay, and you see with that side, angle, side, we form that corner. Okay, that corner is the bit that has to match up. Okay, and there we go. We used a side, angle, side proof again. And, just matching things up the best that you can will do a lot for you in terms of these questions. Okay? It will. Now, this one looks a bit more involved, and there's a bit more going on, which there certainly is. I'd like you to try this one out for yourself, see how you do with it, and see where we go from there. Okay, so countdown to pause. 5, 4, 3, 2, 1, 0. Awkward silence for me to wait, just in case. Then we're going to go for it. Okay. So we got ABC forms a triangle. Yes, it does. We got X, Y, and Z are midpoints of AB, BC, and AC, respectively. And we've got AX, Y, and Z form a parallelogram. We want to prove that Z, Y, C, so this triangle here, and Y, X, B, so this triangle up here, are congruent. Right. Hopefully by this stage you can remember what my step 1 was. My step 1 is to pretend I'm a cowboy and draw. Okay. So, what have I got? Well, I know that this side and this side are going to be equal in length because X is the midpoint. That's the word I was after. So I know that AX equals XB as X divides AB in half. And I know that ZY is equal to AX, which is equal to AB, because ZY is opposite sides of a parallelogram. What else do I know? I know that because this is a parallelogram, that side and that side are equal. And for similar reasons, I know that AZ equals ZC as Z divides AC in half, so similar to above. So I know that all these bits are going to be equal. What else do we know? We know that opposite angles are equal in parallelograms. So we have that. We also have this angle is equal to that angle. What else do we have? We also have, I'm going to bust out the 3 lines. Don't often have to bust out the 3 lines. We have the by, oh god, by equals yc as y divides bc in half. So right now, we want to look at the 2 triangles that we've got and see what information we've already been able to put together. So we've got 3 sides available for each. So there we go. We've got a side proof. We just need to make sure that we get everything together. Okay, so what can we say? How can we link this all together? We can say that zy, I'm going to do this as my second stage now, so my reasons and my statements. Okay. So zy is going to be equal to xb as xb equals ax and zy, zy equals ax because opposite sides in parallelograms are equal. Okay, because there's like a chain of reasoning here. So we've got zy is equal to xb because xb equals ax, which we said above, and zy equals ax. So that side equals that side. Done. We know that az equals xy for the same reasons as above. So as opposite sides in parallelograms are equal, and az equals zc, which equals xy. Okay, so pretty much exactly the same reasons above, just with different sides. So we've got that one is equal to that one. We've got this one is equal to this one. And then we're just left with by equals yc, and which we've said above. And there we go. We have a side proof of congruency. There we go. We can stop. So it looks a brutal question, but it just kind of pretend you're doing a jigsaw, match things up, look for the corresponding bits that you can put together, and that's what makes these questions that little bit easier to manage. Okay. Now, I'm aware that the video's gone on for 33 minutes already, but there are some extra bits and pieces in this PowerPoint that you can have a look at. You might need to find out missing angles, which in triangles you can do. You know, there's no question. You guys can do that. Easy peasy. Okay. One thing I would be careful of is that 2 things. AAA is not a proof. Okay? Angle is not a proof, and neither is ASS. Okay? That is definitely not a proof. Okay? Got to remember which ones are proofs and which ones are not proofs. Okay? These are not proofs. The ones that we had right at the very start, where were they? There they are. Those are proofs. Those are the proofs that we need to know. All right. Um, yeah. I mean, you can go from there. Um, this is a question actually which revolves more around your angles rather than your sides. It would be good for you to try this question out, um, and see how it goes. Uh, my pro tip with this, that focusing on your angles, things like your opposite angles, your alternate, your corresponding angles, things like that will help do this question a little bit easier than just thinking solely about your sides. Okay? And then it's up to you to just do some practice. There's tasks on Hegarty for proofs of congruency, which I think you may have had a go at before. Or you can find exam questions on a website called mathsgenie.com for practicing on those. And if I find anything that's particularly good, I will stick it in the folder as well for you to be able to check. All right. Happy hunting.